Like I said, a lot of times we're good at adding things to areas together, but sometimes you have a hard time seeing. I can take a total area and subtract that little bit out to get our total area. And in fact, for this one, that is the best and almost only way to do it, is I would have to get this total area, and then I would need to subtract out this thing I'm shading in yellow. So I need that total area, and I need to subtract out that little area. So that total area, you can write down total area. I'm just going to put TA for total area. My total area is going to be weird. Someone just asked what 14 times 11 was. Hey Sanjeev, what's 14 times 11? 154. Awesome. All right, then the other one I'm going to call my inside area, IA. My inside area is going to be 7 times 7, which is going to equal 49. So my shaded area, let's call it SA. My shaded area is going to be that total area, 154, minus that 49, which equals 105 feet squared, or square feet. 105 squared feet. Okay, the next one is the exact same thing as that path that goes around a garden. That's why I did that, so we can see that drawing again. So either a path going around a garden, going around a pool, going around a playground, I guess is another one. There's a path going around a playground. To get our shaded area, I have to take this total area here and subtract out this little area here, because I'm just going to pull it out. So our total area for this one, our TA, and I might need a little help on this one because it's decimals, is going to be 27 times 10.8, and what does that equal? 291.6. And then I need my inside area, which is going to be 9 times 9.8, which is going to be 90. Whoa, did I make a mistake? Oh, 19. Okay, and what does that come out to? 8.2. Let's see if that makes sense. So 9 times, so this is how I do this in my head. I do 9 times 20, which would be 180. Minus 2 times that would be 1.8. So it's 180 minus 1. Yep, worked. Okay, so that means my shaded area, let's call it SA, shaded area, is giving me my total area minus 178.2. And what does that come out to? Brian?
113.4.
Thank you, Brian. Centimeters squared. I didn't even see your lips move. That was amazing. Like a ventriloquist.
You could like diss people, but like without
All right. Anywho, that's how I do those two. All right, and this one is just like that pool problem. This is just showing that you can subtract stuff away rather than adding it. Okay, let's go right into homework questions. Homework questions. Do you know it, or?
No, call me last.
Okay. Someone that knows what their homework question is. Ryan.
Number 15.
Number 15.
Can I do it?
Can you do number 15?
Yeah, nope, never mind. I'll take number 16 to see my other question.
Oh, okay.
I feel confident. Why don't we do that too, maybe?
Do what?
Oh, that'll be fun if you have like people go up to the board. Yeah, that's what I mean. Why don't we do that?
So we're going to have so many questions that me just going through is going to take up most of the class period.
No, I'm not.
Well, I mean,
I'm
like,
just
we could have, like,
anytime.
multiple people doing problems on the board.
That's true.
Because then let's get through all the questions in, like, 10 seconds.
Number 15. Well, I need a base and I need a height. Well, the good thing is my height would be that, which would be equal to that. Well, I already have base 1, base 2. Well, if that's 30, this is a 90-degree triangle. So this is a 30, 60, 90-degree triangle. So we have 30, 60, 90, where we have s, 2s, s square root of 3, right? Can we get the height from there? Okay. and then that would be the same height. Well, it doesn't matter if we already have our height. We'd have our base 1, base 2. Okay. Good? Yeah. 26. Oh. Can we stick on this page? Does anyone have a question on this page? Yeah.
22.
Oh man, you really pushed down there. Okay. So 22, the legs of an isosceles trapezoid are 10 centimeters. The bases are 9 centimeters and 21 centimeters. Find the area of the trapezoid and the lengths of the diagonals. Is it the diagonals?
Yeah.
Okay. Then I'm going to do a nice little drawing for you. It's going to be a beautiful drawing. You hate that I do that?
You get that little slit in that slit.
Okay, so we have a trapezoid. We have a trapezoid, and we have bases of 9 and 21. And we have 10, 10, and I assume you already found the area, right? All right, which means you know the height. So let's put that in the middle real quick, and then I'm going to slide it over for a second. So what's my height equal?
I had 8.
8? Is that what other people had?
Yeah.
Okay. That's why we all should be looking at our notes, because it's clearer. All right, that's 8. All right, let me go ahead and not write that there. Let's go ahead and actually put it as a solid line going down right here. All right, which creates a right triangle that if I do that, I make it 8. What do we have there? Nifty little right triangle that we could just do. Thank you, guys. We have a squared plus b squared equals c squared. And both of our triangles are going to be the exact same diagonal length. Okay? All right. So that must mean there's no more questions on this one, so we're on the next. Who had the question that I completely shut down and then, yeah, 26. So an isosceles trapezoid with bases 12 and 16 is inscribed in a circle with radius 10. The center of the circle lies in the interior of the trapezoid. Find the area of the trapezoid. I refer you to your notes. We did this exact problem with the same numbers and everything. Okay. Yeah. 24. 24. Don't worry about 24.
I worried so much about 24.
They're challenge questions. They just will take me like 10 minutes. So some of these are like challenge questions to really stretch your mind, but it'll take me like 10 minutes to go over it. And realistically, I'm more concerned about this one's kind of like the same principle, but I'm more concerned that you can do that one than the other one. So I'm not going to spend a whole bunch of time on that. Same thing with 25. 25 and 24. We're just going to not ask on those. Obviously, if you want to come after school and we can go through them, 100% I'm okay with that. But I'm just saying I don't want to spend 10 minutes where everyone's just like, I don't care, I don't care, I don't care. And then it's not going to be on the test. And it's just for one little thing. All right, Maurice. 30? Okay, number 30 is a good one. Number 30 is a good one. Real quick, Haley, you had a question? Did you want to? Oh, okay. So where are you? Where are you? Okay, so 30 is a tough question. Well, it's not tough. It's just tough. It's pretty tough. All right. What we have to recognize is that it's a tough question where I have two heights. But it turns out I don't know this length. I don't know this length. All I know right now is that it's 10 in between those two things. So we have a distance of 10 here. So I don't know this length. I'm going to call it x. I don't know this length, so I'm going to say that is, well, if we have this is 10, I only have 14 left, so this would be 14 minus that x. Okay, I have a whole bunch of variables And we have to stick with it because there's nothing else I can fill in for them. So we're going to go to the Pythagorean theorem because these are right triangles. And we're going to do it as is. Well, I'm going to have x squared plus h squared equals 13 squared. And I'm going to have over here, I have 14 minus x. Well, it's just, 14 minus x squared plus h squared equals 15 squared. What I would do is I would get my h squareds all by themselves. I'm not going to simplify this too much, but I'm just going to have, for this one, I'll have h squared equals 13 squared minus x squared. On this one, I'm going to have h squared equals 15 squared minus, I didn't have the square in the right place there. Sorry about that. That square should be on the outside. Because it should have been 14 minus x squared. Alright, so that's minus 14 minus x squared. Well, h squared equals these two things, this section and this section. So what I'm going to do is I'm going to do 13 squared minus x squared equals 15 squared minus 14 minus x quantity squared. And then you're going to solve for your x. And once you get your x value, you can plug them in and get your h straight from there too. Okay, because we can just plug our x right in here and I'll figure out what my h equals. Does that quasi make sense? At least enough to get started. Does that make sense to the people that I'm sure had the same question? Or no, or just, what? Okay, other questions? Was that you?
Yeah.
Did you get this one right though?
Yeah, no.
Yeah, no. Does it make sense though, looking up after you woke up? Okay. We'll find out on the test whether you got it or not. All right. Other questions? No, we're good otherwise? Okay. Remember, our test is on Thursday. Okay, area of a regular polygon. And that changes the plygon somewhere. I forgot where. I made a note of it to change it. 100 points to the first person that found it. Oh, I found it. It's right here. Oh, you guys all lost out on 100 points.
What kind of points?
I said, first one to find that gets 100 points.
Yeah, but what kind of
I found it.
cheated?
Don't hate the game. Don't hate the game. Hate the player? No, don't hate the player. Something. Don't hate me. Okay. This is the last area for this test. Alright? It also can create some of the more difficult problems. Not so much difficult, just I can make them lengthier. Okay, so we have polygons, which are like n-gons. You know, we have hexagons, heptagons, septicons, decepticons, Optimus Prime, you know. Okay, so we have polygons. We have polygons. And what we're going to do is we're going to take this polygon and we're going to throw it inside of a circle. Because once we do that, we can find the area of it. Alright, so this only works based upon the fact that we can throw it inside of a circle. So we're inside of this circle, and we have a central point. That central point is not only the center of the circle, it's also the center of our polygon. And that's what we talk about here. Alright, the radius of the regular polygon. Radius of its circumscribed circle. So it's drawn from the center to the vertex. So we've seen these problems before, where we draw that point to a vertex. That is still my radius. Right? That's my radius of my circle, radius of my circle, radius of my circle. It goes to our points. We did that with rectangles, we did that with squares, and it works on the same principle here. If we notice, real quick, and we're going to talk about this in a second, if I have two radii in a row, it creates this awesome angle, which we're going to talk about in a second. But we're going to talk about something that's really important today. It's called an apothem.
It sounds like you're saying opossum with a wisp.
Oh, I got it. My apothem.
Oh, I see it.
Check out that apothem over there. We have one person, all my classes count. Okay, so we have an apothem. We have an apothem. Now I can't stop hearing it.
He's gonna say it at home.
I don't think I've ever heard that or something like that. We got this A word, right? Wait, that almost sounds worse. We have an apothem. A word sounds worse, I think. Okay, so let's regroup. All right, because this is a very important word for us to know. It's the only way we can actually find the area of a polygon is our apothem. And it's a segment drawn from the center of that circle or from that regular polygon. And it's perpendicular to the side of the polygon. Okay, so this line right here is my apothem. I don't think we're going to get through this lesson. This length right here is my apothem because it is a right angle to the side and it connects the center. Note also, this is the altitude of this triangle, right? Do we see how this is the altitude of that triangle?
Yeah, the right triangle.
It forms a right triangle, yeah. So it is the height of this triangle. So that's why it says it's the altitude of that isosceles triangle. It's also the angle bisector. So it bisects this angle in half. It also bisects this segment in half. So if this is 16, this is 8, and this is 8 as well. You guys just stop. You're killing me.
I'm trying.
Me too. All right. Shake it out. Shake it out. Everyone just turn around and I'll just teach you the back.
Don't say that word.
Central angle. Don't worry, there'll be a time where I can move to the back, then you can't see me when we go. Okay, but not right now. We have the central angle that I already brought up. We have that central angle that I already brought up, which is this angle here. That is my central angle. It is the one that's created with two radii. So radii creates a central angle. We need to know that because, like I said, this triangle is going to be very important because I need to know this length. All right, we're going to be always finding this. So central angle of a regular polygon is an angle whose vertex is at the center of the polygon. What we need to put down here, we can actually calculate that degree based upon what type of polygon it is. Because if we look at this, I have a central angle here, I have a central angle here, a central angle here, central angle here, central angle here. In other words, let me just go ahead and color those guys in. Let's go ahead and use purple. So if I keep cutting this into pies, kind of like a pizza, we have 1, 2, 3, 4, 5, 6 slices. How many degrees are in a circle?
360.
360. How do you think you calculate one of these angles?
360 divided by 6.
360 divided by 6. So our central angle is going to be 360 divided by n, where n is the number of sides. All right, so that's going to get us our central angle, and it's going to be key to solving a lot of our problems. All right, real quick, before we read all this, we're going to go through all this information without reading it right now. So, if I could find that area of this triangle, which would be our height, half a base times our height, right? So half our base times our height gets me the area of this. If I find the area of this, and then I just multiply it by 1, 2, 3, 4, 5, 6, that would be the total area of my polygon, right?
Right.
So all I need is the height of this, and I need this length here multiplied by how many there are. And I have the area of that. And that's what we start with. We start with area of one triangle, multiply that by how many triangles we have. Well, the area of one triangle is half of base times height, right? So we have half of base times height. Maybe I'll box that in, because that's my area of my triangle. That's all I rewrote there. And then it's times the number of triangles. Well, we shorten that. Instead of having the words, we have half of S. That's our side length. A is my apothem,
Which is a height.
which is my height. Yeah. My height is my apothem. So all I did is I switched out, instead of saying base, it's my side length. Okay, my side length. And instead of height, I use apothem. And then, for number of triangles, I still have number of triangles. Okay, so we're going to keep going down. I'm going to organize this differently. I have 1/2 of A times our number of sides times our sides. Well, number of sides times our sides is just side plus side plus side plus side plus side, which is our, what happens when I add all my sides together?
Perimeter.
Perimeter. I have my perimeter. So rather than say number of sides times my side lengths, we just have half of A times P, where P is our perimeter, and A is our apothem. Okay? So it's just, we just need 2 bits of information to find the area of our regular polygons. I need my apothem, and then I also need my perimeter. Alright, we need those 2 bits of information. Think of that every time you're doing these problems. Do I have both of those? If I do, I'm done. If not, we have to figure out how to get there. And so our formula is right here. Half of A times P. Okay, quick, someone tell me what's the center of this circle? Yes. Yeah. That's one I'd raise my hand on too. Because they could get harder, right? Someone else, what's the radius? Name one radius. Hasn't. F and B. All right, someone besides Mazim. Brian. F-A. Can someone name another radius? Ooh, Hannah.
It's not there.
Oh, FD. I thought you said FD. Okay, and the list goes on, right?
He said FD. I thought you said FD.
FD.
No, Mr.
She
said FD, and he said, oh, I thought you said FD.
No, I thought you said FB. I thought you said FB, and I paused for a second. I'm like, we already did that one. All right, so any point that connects to our, is FG a radius?
Yeah, no.
No, it doesn't go to the edge of the circle. Awesome. Name it apothem. Don't actually come up with a name like Charlie or something. Yeah. FG.
Wait, can you explain the definition of that?
Someone name the central angle that's already drawn up there for us.
Wow.
There are actually 5 angles that say F. Can someone pick the actual one? Haley. BFA. Angle BFA. Another one might be angle BFC. We might have angle CFD, and the list goes on from there. Those are all central angles. All right, now we need to find each angle's measure. So I want to find the measure of angle AFB. Who can tell me how to find AFB and also get it? Someone that I have it. Sanjeev. Yeah, I'm going to divide 360 by the number of sides, which is 360 divided by 5. And what does that come out to? 72 degrees. So based upon that, can someone give me AFG?
35 degrees.
Can someone raise their hand and give me, so I can call them? Yeah.
36 degrees.
36 degrees. I'm glad you changed it too. It was like 35 for a second there. All right, can someone raise their hand and tell me what GAF, angle GAF is going to be? Take your time because it's not BFG. It is GAF. Fritz, you think you can get that one?
At least he's honest.
Shh. No, he can't. We have a triangle, right?
Oh, wait, let me get him out.
Okay, you know what to do though?
Yeah. I don't. Wait, is it 54?
It is 54 degrees.
How do you
Because we know that AFG is 36 degrees. It creates a triangle, so 36, 90. I just got to figure out what that missing angle is. Okay? So you get that this is 36. That's where we got. It's half of our central angle. Okay. All right. All right. Our next one is we need to find the area of the regular pentagon. ABCDE with side length of 16 inches.
Don't you need more information?
What do we need? What two things do we need? Who can say it without laughing?
No.
Who wants to take a shot at it? I just need 2 bits of information. Someone I haven't talked to yet. I've talked to you several times.
Well, I want to talk to you more.
David, what 2 bits of information do I need? Yep. And? No. Look down at the bottom. Our equation here. Apothum and perimeter. Yep, we need apothum and we need perimeter. Well, I don't have either thing yet, but I can get perimeter really, really easy because perimeter equals 16 times 5. Yep. Which is going to equal 50 plus 30 is 80. So we have perimeter. We have our perimeter. That's good. That's one thing. Now I need to get my apothum. So what we're going to do to get is we're going to draw that central angle. All right, I'm pulling an angle out of that pentagon. So we'd have more, right? This is just one of those triangles that are pulled out of it. Well, we said the central angle of a pentagon is 72 degrees. Each of these is 72 degrees. So this measure up here is going to be 72 degrees. And how we got that, just a real quick reminder. That would be 360 divided by 5 equals 72 degrees. All right, so if I continue down, if that's 72 degrees, this must be 36 degrees. That barely looks like 36. 36 degrees. We have a right angle, and on the very bottom, that bottom length right here, that guy's going to be 16 inches. So that means that this is 8 inches. I need the height of this, because once I have the height, my height is actually my apothum. All right? So this is actually my A value. You can either call it A or H, whatever you can keep track of. I'm going to go ahead and call it A for the time being. I know it's the height of the triangle, but it is our apothum for our pentagon. Okay, so we have A right there. Do I have a 30, 60, 90 degree triangle?
No.
No. Do I have 45, 45?
No.
So that tells me I have to use trig. It's not that bad. All right, who can tell me which trig function I need for opposite and adjacent? Because I'm looking at 36, I have an adjacent, I have opposite. Which one does opposite and adjacent? Tangent. Yep. So we're just going to do that work. We're going to say tangent. Let's go ahead and go down. So tangent of 36 degrees is going to equal opposite over adjacent. I'd multiply both sides by A. So we'd have A times tangent of 36 degrees equals 8. So that's when I multiply both sides by A. And we divide both sides by tangent of 36 degrees. So we'll have A equals 8 divided by tangent of 36 degrees, which should be, running again, so that should equal 11 when you plug in your calculator. Well, like I said, this height is our apothum. We only need 2 bits of information. I need a perimeter, I need an apothum, and then we're done. So we're just going to jump right to our answer, which is A equals half of our apothum. This one is 11. And our perimeter is 80. So who can give me the area of this shape? Emma? 140. Inches squared. Good. So most of the time we're going to pull out a triangle, and it's going to help us solve it. Our next one you should look at and be like, oh man, I hope that's on the test.
Oh, I hope that's not.
Because it's really fast.
Because it's really fast because they give me my perimeter and the apothem, which means all I can do is just go, okay, I know what that formula is, Mr. Pabian. It's just area equals 1/2 my apothem times 7. And that's going to go ahead and equal just, no, it doesn't equal that. What does that come out to? 392. There you go. I forgot I didn't actually write an answer down on here. Okay. One more problem. The good thing is I'm pretty much doing the hard ones. A lot of the ones that are on the worksheet are going to be easy to start off with. They're going to basically give you the information you need. Or they might work backwards. They might say the area equals and my sides are this length, find your apothem. All right, so a regular hexagon has perimeter 216. Oh, good, we have our perimeter. This has got to be an easy one. Because we already have half the problem done. We have our perimeter. What is the area? Ugh. That means I need to draw a picture. I need to draw a hexagon. A hexagon has how many sides? 100? Oh, I was way off. 40. So we have 6 sides. Well, that's pretty good for me. How do I figure out what's the length of each of those sides? You got a hand.
216 divided by 6.
So number of side length is going to equal 216 divided by 1, 2, 3, 4, 5, 6. And what does that come out to? What'd you come out with? 36, yeah. So each of these is 36. No, that's 33. Bless you. 36, 36, 36, 36. Did Mike just shush someone? I was like, that's the pot calling the kettle black. All right, so we have all our sides are 36. That's all I know. Okay, so that tells me I'm going to draw a central angle. All right, when all else fails, I'm going to draw a central angle. That's when all else fails on these problems, I draw a central angle, and I get the measure of that angle. So my central angle how do I find the measure of my central angle? Can we refrain ourselves from just shouting out answers? Otherwise, we'll find a more permanent solution. All right, how do you come up with it?
Oh, you have to divide the perimeter by the sides.
Not gonna do the perimeter. Yeah.
Don't you do 360 by number?
Yep. I'm gonna do 360
Got him.
divided by the number of sides, which is 6 sides, which equals 60 degrees. So that central angle is 60 degrees. Now, you can do all your work in there. I like to pull out that triangle so I can make it a little bigger and see what I'm focusing on. So I'm going to go ahead and redraw that triangle. Doom, doom, doom. Good. All right, I know. Let's go ahead and draw our height. But our height is also called our... Everyone is called our... It's called our apothem. Yeah, thank you. Thank you, Jack. It is our apothem. And our apothem cuts that angle right in half. If our angle's 30, that makes this, or 60 is going to make our new angle 30 degrees, 30 degrees. This is a right triangle, so it's 30, 60, 90. The base is 36, so this is actually 18. 18. I have 30, 60, 90 triangle. Cuckoo, ka-choo. All right, so just remember with 30, 60, 90, we have an S. We have 2S here. I have S square root of 3 on there. So I really only care about this length here. So if my S is the 18 side, that means that S equals 18, which means our A value, so our A is that S square root of 3, so A is going to equal 18 square root of 3. That's my apothem. I already have my perimeter. So our area is going to equal 1/2 my apothem times my area, which is 216, which is going to equal 1944. 1944. 1944
Wait, how did you?
square root of 3. I can see from, no, I can't. A little bit of mental math.
9 times 200. Oh yeah.
Yeah. You can break down to 200s. And
16 times 900.
all right, any questions on anything we did?
No, there.
All right, your homework is the worksheet. Let's pay attention really quick, because you don't have to do one of them. Oh, now they come back out.
Oh, they pull it back up.
You do not have to do number 11. Number 11. Number 12 and 13 are tough. Number 13 is really tough if you don't think about it a certain way. So if you're really, really stuck, I am going to post my answer key online tonight. So if it's not posted, let me know.
Oh, that's all right.
You'll learn. You will learn. You will learn.
Heptagon?
Yep, you got it.
That sounds good.
Hep-
Over 12, is it our best winner?
Yeah, they're all assumed to be regular.
I guess we're close.
We still have a couple minutes, so either you can sit there and stare at your blank desk, or you can work on them, but we aren't going to refrain to talking the rest of the time.